Transportation problem. Distributing any commodity from any group of supply centers called sources to any group of receiving centers called destinations in such a way as to minimize the total distribution cost, that is a shipping cost. Total supply must equal total demand. If total supply exceeds a total demand, a dummy destination whose demand equals the difference between the total supply and total demand is created. Similarly, if total supply is less than total demand, a dummy source is created whose supply equals the difference. A unit shipping cost into a dummy destination or out of a dummy sources are 0. The example 1, the destinations are D1, D2, D3, D4 and the sources are S1 and S2, S3. The demand is in this problem the demand is equal to supply. This problem is a balanced transportation problem. The example 2, the supply is not equal to demand, therefore we add the dummy destination are 0, 0, 0, 0. The general form of transportation table, the shipment will be placed here and shipping cost. The initial solution procedure. First to type a northwest corner starting procedure. Select the minimum variable in the upper left, the northwest corner, and note the supply remaining in the row S and the demand remaining in the column D. Allocate the minimum of S or D to this variable. If this minimum is S, eliminate all variables in its row from future consideration and reduce the demand in its column by S. If the minimum is D, eliminate all variables in the column from future consideration and reduce the supply in its row by D. And repeat these steps until all supplies have been allocated. The example of northwest corner rule. First we will start in the cell is north. Second type, a least cost starting procedure. For the remaining variable with the lowest unit cost, determine the remaining supply left in its row S and the remaining demand left in its column D. Break ties arbitrarily. Allocate the minimum of S or D to this variable. This minimum is S. Eliminate all variables in its row from future consideration and reduce the demand in its column by S. The minimum is D. Eliminate all variables in the column from future consideration and reduce the supply in its row by D. Repeat these steps until all supplies have been allocated. The general form of the transportation problem. This is the example of least cost method. Third type, a Vogel's approximation method starting procedure. For each remaining row and column, determine the difference between the lowest two remaining costs. These are called the row and column penalties. Select the row or column with the largest penalty found in step 1 and note the supply remaining for its row S and the demand remaining its column D. Allocate the minimum of S or T to the variable in the selected row or column with the lowest remaining unit cost. If this minimum is S, eliminate all variables in its row from future consideration and reduce the demand in its column by S. If the minimum is T, eliminate all variables in the column from future consideration and reduce the supply in its row by D. Repeat these steps until all supplies have been allocated.